Good afternoon. My name is Xiaochun Lu. I'm application engineer for Rakon, America. I'm very excited standing here today because last year I was here and did not see as many people as today. And also, what we can say is last year, majority of us here still putting the mask on, and this time is now. So great job, OCP. All right, so my topic today actually is still about the oscillator, but it's more about the holdover, the implementation consideration. So that's gonna be the simple, but quite important. So when we talk about the oscillator holdover, we have to go back to what the standards requirement. And so the reference model is quite familiar with the majority of people here. It's coming from the ITU G.8271, and for the phase holdover, the requirements. So what we can say is, where's the laser? Oh, works. So from the primary reference timing clock to passing through the whole network, it's actually within the very stringent requirements, 1.5 microsecond. So we can imagine how difficult to achieve that. And that's where the G.8271 required. But meanwhile, we also look at the different kind of the aspects, the requirements for, in addition to the phase, there are also the frequency accuracy requirements for the holdover. So that's using today's 5G wireless network requirements, we can say for the frequency domain, in the frequency domain, the frequency accuracy requirements actually is straightforward, 50 ppb, straightforward. But when we look at the phase for the time alignment error requirements, it's still very stringent with that magic number, 1.5 microsecond. So, such as, in this one, in the time alignment requirements in the phase, in the time domain, such kind of the requirements actually are multiple defines, such as, within any two radios in the same radio head, 65 nanosecond. It's very stringent. But no matter what, for the base station, between the base station, 1.5 microsecond, the magic number, still playing the requirements here. So we see how challenger, the holdover is required. Talking about the timing support network, there are two typical topologies. One of them is so-called the full timing support network, FTS. And the parallel with that is another one. Actually, my colleague mentioned that before. It's a partial timing supporting network with the PTS. What's the difference between the two different kind of the network topologies? The first one not only require all the nodes within the network require with the PDP support, but also with the physical layer, the timing clock requirements, which is typically with the sync E. And also another common, the elements, but for the PTS, for the partial timing supporting network, no physical layer required. However, PDP is still the essential requirement. So compare the two different kind of the timing supporting networks topologies. The one thing is common. Actually, that's the GNSS clock as the primary resource of the reference clock. That's shared with all timing supporting network. When we talk about those kind of the requirements for the network, timing supporting network, those kind of the holdover scenarios is become the kick in. So quite a common scenario for the holdover. If we lose the GNSS, the primary reference clock, well, it's naturally this network will switch into the next resource of the reference clock, which is the PDP. When we're losing the PDP, and then if we have the sync E in the like a PTS model, we will switch to the physical layers, the clock, as the reference, time, clock reference. But in the case, if we lost everything, don't think that's gonna happen. It does happen. So in that kind of the situation, the timing supporting network has to rely upon the local oscillator holdover capacity to supporting the timing network. So that's the scenario for the holdover. And eventually, we see those oscillators become the last lifeline for the timing. A good news is, after so many years, research, study, and engineering experiments, all those things, eventually we actually have the model to describe the oscillators holdover performance. So here, actually, I hope it's on the right side. So we have this model, the quadratic equation, to describe, to modeling the holdover performance for the oscillator. So as our, I should not say it's a comrades, with all those experts from this industry, we know so many factors. We have the long list of the parameters, try to describe about the oscillators, the performance. Among those things, we have the initial, the phase offset. We also have those kind of frequency, initial frequency deviation, all those kind of, but among them, the most significant the factors impact with the oscillators performance are temperatures, such as temperatures, even the input voltage variation, including all the circuits, the load, all those kind of factors, they impacted with the holdover performance with the oscillator. Well, the more important thing actually is the agent in the oscillator stability. Agent is just one of the so many parameters impact with the oscillator's stability. However, in the holdover situation, the agent actually is located in the quadratic term. That means this agent factor will significantly impact the holdover performance for the oscillator during the holdover duration. So that's where this model displayed. So this is the lab drawing curve with this. I will go over this detail. So eventually, we narrow down those kind of so many parameters impact with the holdover performance in the oscillator. But eventually, we narrow down those into the two major categories. One is temperature. It's just like impact as serious as the stability. But for the holdover, it's still the significant impact with the holdover, the performance. But the only good news, I should not say good news, I'm just saying, in this case, what we say is actually a linear relationship for the temperature impact with the holdover. So what we can say is the temperature, here the blue curve describes the lab temperature variation by giving the time during the holdover duration, given the time vary. And with that, what we can see, the green line, this is the green curve, actually describe the linear, it reflects the linearity relationship between the holdover performance and the holdover, the duration time. Now, this actually is more significant impact with the agent parameter. This is a quadratic equation. The quadratic impact, we can see the green line, green curve describe this impact during the holdover, the duration. And at the end, we will have the combined the impact for the holdover performance with the oscillator actually come with the yellow line. So let's go back to that magic number, which is 1.5 microsecond. So what from this lab data, so what we see actually is of the oscillator with the holdover until about after the 4 hours holdover and the passing over the standard requirements. So that's why this one basically describe how the performance, the holdover is doing with those kind of two major factors impacts. Now, if we have those kind of the characteristics built up, then how we can basically improve the oscillator's holdover performance is a quite natural thinking. One of the way implementation consideration for the oscillator to have the enhanced holdover ability is do the compensation to those kind of the two factors impact. So that's where we actually implemented with this compensation apply to the oscillator in order to maintain this kind of eventually the phase error within the 1.5 microsecond. Here's the block diagram with that implementation. So implementation actually is quite straightforward. So we're using the GNSS clock as the primary reference clock. And then through those kind of the reference clock, we build up the characteristics model within those the oscillator. Then we have those kind of the so-called factor compensator back to the feeding back with the oscillator. So eventually make the oscillator performance within 1.5 microsecond with the certain duration of the time. If we wanted today some oscillators with the holdover ability, we do have this choice. We do have that in the market. So given the form factor with the 14 by 9, we can do 4 hours and even higher. But if you really want 25 by, if you really want 24 hours holdover ability, that oscillator currently we can offer with 25 by 22. So you do have the choice. If you want more, please visit that website. Am I on time? Or too short?
Oh no, we're good. So, okay, let's open for questions. Please.